Climate change is one of the most pressing challenges of our time, demanding urgent and effective mitigation strategies. While reducing greenhouse gas emissions remains the primary approach, complementary strategies like carbon sequestration and avoided deforestation have gained traction. These carbon projects not only aim to capture and store carbon, but also promise benefits for nature conservation and local development. However, their implementation is not without controversy. Alongside their positive impacts, carbon projects can also bring about significant environmental and social challenges. In this video, we'll explore the complex landscape of carbon sequestration initiatives, their intended benefits, and the often overlooked risks and trade-offs that come with them. Carbon sequestration refers to the process of capturing and storing atmospheric carbon dioxide, typically through natural means like forests or engineered solutions. Forests play a crucial role in this process, acting as carbon sinks due to their large biomass and the ability of their soils to store carbon over long periods. Carbon projects often focus on afforestation, reforestation, or protecting existing forests to enhance this natural service. These efforts are seen as vital tools in the fight against climate change, but their effectiveness and permanence are subjects of ongoing debate. Understanding the basics of carbon sequestration is essential before diving into its broader impacts. There are two main types of carbon projects: those that focus on sequestration, such as afforestation and reforestation, and those that aim to maintain existing carbon stock by avoiding deforestation. Afforestation involves planting trees on land that hasn't been forested for decades, while reforestation restores trees to areas where forests have been lost. Avoided deforestation projects, on the other hand, protect threatened forests from being cleared. Each type of project comes with its own set of benefits and challenges, and their impacts can vary widely depending on the region, ecosystem, and management practices involved. Carbon projects are often promoted for their multiple benefits. Not only do they help mitigate climate change by capturing carbon, but they also support biodiversity, regulate water cycles, and provide resources for local communities. Forests deliver a range of ecosystem services, from provisioning timber and non-timber products to regulating climate and supporting cultural values. When designed thoughtfully, carbon projects can contribute to sustainable development and poverty alleviation, offering a holistic approach to environmental and social challenges. However, realizing these benefits requires careful planning and ongoing management. Despite their promise, concerns about the effectiveness of carbon projects persist. Accurately quantifying the amount of carbon sequestered can be challenging, especially in tropical regions where data is limited. There's also the issue of additionality, ensuring that the carbon captured is truly above what would have occurred without the project. Some projects may overstate their benefits or fail to address the root causes of deforestation. Moreover, emissions from project implementation such as machinery use or fertilizer application can offset some of the gains. Ensuring credibility and transparency in carbon accounting is crucial for these projects to deliver real climate benefits. Key challenge for carbon projects is ensuring the permanence of stored carbon. Forests can be vulnerable to disturbances like wildfires, pests, droughts, or changes in land use, all of which can release stored carbon back into the atmosphere. The risk of abrupt carbon loss means that long-term monitoring and contingency plans are essential. Some experts argue that carbon storage should be valued over centuries or even millennia, not just decades. Without robust guarantees of permanence, the climate benefits of these projects may be temporary or even reversed. Forestation and reforestation can influence the climate in unexpected ways. One major concern is the reduction of surface albedo, the reflectivity of the land. When dark forests replace lighter surfaces like grasslands or snow, more solar energy is absorbed, potentially increasing local and even global temperatures. This effect is particularly pronounced in boreal and temperate regions. In some cases, the warming from albedo reduction can outweigh the cooling benefits of carbon sequestration, leading to what's called malmitigation. Understanding these biophysical feedbacks is critical for designing effective climate strategies. Forests play a complex role in the water cycle, and large-scale tree planting can have both positive and negative effects on water resources. In many cases, afforestation increases evapotranspiration, reducing runoff, stream flow, and water yield, especially in arid and semi-arid regions. Some studies report significant reductions in water availability following afforestation, while others find that increased forest cover can enhance rainfall and groundwater recharge in certain contexts. The impacts are highly site-specific, making comprehensive hydrological assessments essential before launching new projects. Tree plantations can alter soil properties in several ways. Fast-growing species often used for rapid carbon sequestration may extract large amounts of nutrients, leading to reduced soil fertility over time. In arid regions, afforestation can lower soil moisture and increase the risk of wind erosion. The use of fertilizers and agrochemicals to boost tree growth can further impact soil and water quality. Some carbon offset standards overlook these soil impacts, underscoring the need for integrated land management approaches that consider both above and below ground effects. While carbon projects can support biodiversity, they can also threaten it if not carefully designed. Monoculture plantations, especially with non-native species, often reduce habitat diversity and can lead to biotic homogenization. Planting trees in historically non-forested ecosystems like grasslands or savannas may harm unique species adapted to those environments. On the other hand, integrating carbon and biodiversity goals such as using native species and protecting intact ecosystems can yield significant co-benefits. Balancing carbon sequestration with biodiversity conservation remains a major challenge. Visual impact of large-scale plantations can alter landscapes, sometimes diminishing scenic and recreational values. Projects that prioritize rapid carbon gains may favor uniform, fast-growing species, resulting in less visually appealing or ecologically rich environments. In contrast, diverse and well-managed forests can enhance both the beauty and ecological value of landscapes. Considering local preferences and cultural values is important when planning carbon projects, as these factors influence public acceptance and long-term success. Forestation and reforestation projects often compete with agriculture for land, especially in regions where productive farmland is limited. This competition can reduce the area available for food production, potentially raising food prices and affecting local food security. In some cases, agricultural activities are displaced to new areas, leading to indirect land use change and possible biodiversity loss. Agroforestry systems, which combine trees with crops or livestock, offer a potential solution but require careful management to avoid negative trade-offs. When land is diverted from agriculture to carbon projects, local communities may lose access to essential resources for food production and gathering. This is particularly concerning in tropical regions, where many people rely on forests and surrounding lands for their livelihoods. Reduced access to land can lead to higher food prices, decreased agricultural exports, and increased vulnerability among the poorest population. Ensuring that carbon projects do not undermine food security is a key consideration for sustainable development. Carbon projects can have profound social impacts, especially in developing countries where forest-dependent communities may lack formal land rights. Protecting forests or establishing plantations can restrict access to land and resources, threatening traditional livelihoods and cultural practices. In some cases, local people are marginalized or become dependent on external actors, such as companies or NGOs. Equitable benefit sharing, respect for traditional uses, and genuine public participation are essential to avoid exacerbating poverty and social inequality. Social impacts of carbon projects are not felt equally. Women, especially those heading households without land titles, are often excluded from project benefits and may suffer disproportionately from restrictions on land use. Power imbalances can allow local elites or outside investors to capture most of the gains, leaving vulnerable groups behind. Addressing gender and social equity in project design and implementation is crucial for achieving just and inclusive outcomes. Effective public participation and procedural justice are often lacking in carbon projects, particularly in avoided deforestation schemes. Without meaningful involvement of local stakeholders, projects may fail to address community needs or respect traditional rights. Transparent decision-making, inclusive consultations, and mechanisms for grievance redress are vital for building trust and ensuring that projects deliver on their promises. New verification schemes are emerging to strengthen social safeguards, but challenges remain. Economic benefits and costs of carbon projects are often unevenly distributed. While the global community may gain from reduced emissions, local communities may bear the costs, such as lost livelihoods or restricted land use. Carbon markets can drive up land prices, making it harder for the poor to access resources. In some cases, projects are designed to maximize profits for external actors, with little regard for local development. Ensuring that economic gains are shared fairly is essential for ethical and sustainable carbon initiatives. Carbon markets and offset schemes can have unintended political consequences. By allowing wealthy countries to offset their emissions through projects in poorer regions, responsibility for climate action may be shifted away from major emitters. This can undermine the sovereignty of host countries and restrict their ability to manage natural resources. Ethical concerns arise when projects prioritize external interests over local needs, leading to accusations of green colonialism or green grabbing. Leakage is a major risk in carbon projects, especially those focused on avoided deforestation. When forests are protected in one area, logging or agricultural expansion may simply move to another region, negating the climate benefits. This displacement can occur locally, nationally, or even internationally, often impacting areas with weaker protections or higher biodiversity. Addressing leakage requires coordinated policies and careful monitoring to ensure that carbon gains are not offset by losses elsewhere. Let's look at a real-world example of hydrological impacts. In China's Les Plateaux, large-scale afforestation projects have aimed to restore vegetation and sequester carbon. While these efforts have increased surface water in some areas, they have also led to reduced water yield and lower groundwater tables in others. The outcomes depend on local climate, soil, and species selection. This case highlights the importance of site-specific assessments and adaptive management in carbon projects. In tropical regions, avoided deforestation projects under schemes like REDD+ have sometimes led to social tensions. Local communities, often lacking formal land rights, may be excluded from decision-making or denied access to forest resources. In some cases, enforcement against illegal logging has resulted in arbitrary arrests of the poorest residents. These experiences underscore the need for robust social safeguards, equitable benefit sharing, and respect for traditional knowledge and practices. Optimizing both carbon sequestration and biodiversity protection is challenging. Projects that maximize carbon gains often do so at the expense of ecological diversity, especially when using monocultures or non-native species. Conversely, prioritizing biodiversity may reduce the amount of carbon stored. The best outcomes are achieved by integrating both goals, using native species, protecting intact ecosystems, and designing projects for multiple benefits. This approach may be more costly, but delivers greater long-term value. Agroforestry, which combines trees with crops or livestock, is often proposed as a win-win solution for carbon sequestration and agricultural production. In practice, the results are mixed. While agroforestry can enhance soil health, diversify incomes, and store carbon, it may also reduce crop yields due to shading or competition for water. Success depends on local conditions, species selection, and management practices. Careful planning is needed to ensure that agroforestry delivers on its promises. Monocultural plantations, especially those with fast-growing exotic species, are more susceptible to disease and pest outbreaks. These risks can threaten the permanence of carbon storage and lead to abrupt carbon releases. Diverse mixed-species forests are generally more resilient, supporting both carbon and biodiversity goals. Project designers should consider ecological resilience and avoid over-reliance on single-species plantation. Forests are increasingly vulnerable to wildfires, especially as climate change intensifies droughts and extreme weather. Fires can rapidly release stored carbon, undermining the climate benefits of sequestration projects. Effective fire management, early warning systems, and adaptive strategies are essential to safeguard both carbon stocks and local communities. Projects must account for these risks in their design and operation. Any carbon projects rely on ongoing financial incentives to maintain forest cover. If payments cease, landowners may revert to previous land uses such as agriculture or logging, resulting in the loss of stored carbon. This dependency highlights the importance of sustainable funding mechanisms and long-term commitments from both project developers and buyers of carbon credits. Quality of carbon projects is often determined by market prices for carbon credits. When prices are low, there may be little incentive to invest in high-quality, socially and environmentally responsible projects. This can lead to a race to the bottom, with projects cutting corners or neglecting important safeguards. Strong standards, transparent verification, and consumer demand for ethical offsets can help drive improvement. Green grabbing refers to the appropriation of land and resources for environmental purposes, often by external actors. In some cases, carbon projects have been accused of perpetuating green colonialism, where wealthy countries or organizations impose conservation measures on poorer regions, sometimes at the expense of local rights and development. Addressing these ethical concerns requires genuine partnership, respect for sovereignty, and prioritization of local need. Old-growth forests provide ecosystem services that young plantations cannot match, including greater biodiversity, climate regulation, and resilience to environmental change. Replacing mature forests with plantations, even for carbon gains, is counterproductive and can take centuries to recover lost functions. Protecting existing old-growth forests should be a top priority in any climate or conservation strategy. Designing carbon projects involves weighing multiple trade-offs between carbon sequestration, biodiversity, water resources, social equity, and economic returns. There is no one-size-fits-all solution, and priorities may differ by region and stakeholder group. Transparent, participatory decision-making processes are essential to balance these competing interests and achieve the best possible outcomes. Proper environmental impact assessment (EIA) is crucial for identifying and managing the risks of carbon projects. EIA should consider both direct and indirect impacts, including leakage, social effects, and long-term sustainability. International best practices recommend involving all stakeholders, ensuring transparency and adapting management plans as new information emerges. A robust EIA process can help maximize benefits and minimize harm. Transparency and public participation are foundational to the success of carbon projects. Open sharing of information, inclusive consultations, and mechanisms for feedback and accountability build trust and improve project outcomes. Projects that engage local communities from the outset are more likely to deliver lasting benefits and avoid conflict. These principles are increasingly recognized in international standards and certification schemes. Holistic approach to carbon projects integrates climate mitigation with nature conservation and poverty alleviation. This means designing projects that deliver multiple benefits: carbon storage, biodiversity protection, water regulation, and improved livelihoods. Such integrated strategies require collaboration across sectors, adaptive management, and a commitment to long-term sustainability. When done right, carbon projects can be powerful tools for positive change. Experts recommend several steps to improve carbon project outcomes. Account for uncertainty and errors in carbon measurement. Assess both mitigation and potential contributions to climate change. Define and guarantee permanence. Create contingency plans for risks like fire or drought. Promote locally led projects. Propose alternative livelihoods. Ensure fair benefit distribution. Combine timber and carbon goals and minimize leakage. These recommendations help guide responsible project design and implementation. Long-term monitoring and adaptive management are essential for addressing the dynamic challenges of carbon projects. Regular assessment of ecological, social, and economic outcomes allows for timely adjustments and continuous improvement. Adaptive management recognizes that conditions change and that learning from experience is key to achieving lasting success. Certification schemes, such as those for carbon offsets or sustainable forestry, play a growing role in ensuring project quality. These schemes set standards for environmental and social performance, require independent verification, and provide transparency for buyers and stakeholders. While not perfect, certification can help drive improvements and build confidence in carbon markets. Addressing the global challenges of climate change, biodiversity loss, and social inequality requires international cooperation. Carbon projects often span national boundaries and involve multiple stakeholders. Harmonizing standards, sharing best practices, and supporting capacity building in developing countries are essential for scaling up effective and equitable solutions. Ongoing research and innovation are needed to improve carbon project outcomes. Advances in remote sensing, data analytics, and participatory mapping can enhance monitoring and transparency. New approaches to integrating carbon, biodiversity, and social goals are emerging, offering hope for more effective and just climate solutions. Supporting research and learning is vital for continuous progress. Ethics play a central role in the design and implementation of carbon projects. Projects must respect the rights and needs of local communities, avoid perpetuating inequalities, and ensure that environmental gains do not come at the expense of social justice. Transparent, inclusive, and accountable processes are essential for building legitimacy and trust. Recap: carbon projects can deliver significant climate, ecological, and social benefits, but they also carry risks and trade-offs. Key impacts include changes to water cycles, soil health, biodiversity, food security, livelihoods, and local economies. The balance of these impacts depends on project design, local context, and ongoing management. Recognizing and addressing these complexities is essential for success. Experience shows that one-size-fits-all solutions rarely work. Projects that are locally led, context-specific, and designed for multiple benefits tend to perform better. Early and ongoing engagement with stakeholders, adaptive management, and strong safeguards are critical for minimizing harm and maximizing positive outcomes. Learning from past successes and failures helps guide future action. Moving forward, the challenge is to design carbon projects that are effective, equitable, and sustainable. This means integrating climate, ecological, and social goals, ensuring robust monitoring and transparency, and building partnerships across sectors and borders. With thoughtful planning and commitment, carbon projects can be a force for positive change in the fight against climate change. Carbon projects are not a silver bullet, but they are an important part of the climate solution. Their success depends on recognizing and managing the trade-off between environmental, social, and economic objectives. By adopting holistic, inclusive, and adaptive approaches, we can maximize the benefits of carbon projects while minimizing their risks. The future of climate action depends on our ability to learn, adapt, and work together. As individuals, organizations, and policymakers, we all have a role to play in shaping the future of carbon projects. By demanding transparency, supporting ethical and effective initiatives, and staying informed about the latest research, we can help ensure that carbon projects deliver real and lasting benefits for people and the planet. Thank you for joining us on this exploration of the environmental and social impacts of carbon sequestration projects. The path to a sustainable future is complex, but with knowledge, collaboration, and commitment, we can navigate the challenges and seize the opportunities ahead. Let's work together to create carbon projects that truly benefit both people and the planet.